Hello, my name is Jonathan Heckel. In this tutorial, I'm going to show you how to simulate two-dimensional airflow through a duct in ANSYS. When you open ANSYS Workbench, you should see something like this. What we're going to do is go over to the toolbox on the left and double-click on Fluid Flow parentheses Fluent. That should bring up this pop-up. We're going to rename it to 2D Convection. And now the default analysis mode in ANSYS is three-dimensional. So to change that to two-dimensional, we're going to go over here to Geometry, going to right-click, select Properties. That'll bring up this pop-up on the right here. We're going to go down to Advanced Geometry Options, and then under Analysis Type, we're going to change that from 3D to 2D. We can close that. And now we should be all set up and ready to do the actual analysis. So to get started, we're going to right click again on the Geometry tab here and go down to New Design Modeler Geometry. So this is the Design Modeler. The first thing we want to do here is check that we're using the correct units. To do that, we're going to go up to the Units tab here in the top left, click on that, and verify that we are using the correct units, which is meters. Next thing we're going to want to do is right click on the XY plane here, click Look At. That'll give us this new flat perspective. And now we can start actually working on the sketch that we're doing. So if we click the Sketching tab here, first thing we want to do is go to Settings and set up our grid. So click the grid setting here, click Show in 2D and Snap. We want those both on. For major grid spacing, we want 5 meters. And for minor steps, we want 5 as well. Now, if you've ever used a CAD software before, this process is going to feel pretty familiar. In the Drawing tab here, we're going to click the rectangle with 2 points. And we're going to put the first point at the origin and then put the second point just wherever. And now we're going to dimension this rectangle. So for our first dimension, we're going to click the Dimensions tab, click on Horizontal, hold left Control, and then left click on the 2 vertical faces of the rectangle. And then that's going to give us this dimension H1. In the Details view in the bottom left here, we're going to change that from, it's currently 34, we want it to be 15 meters. And now we're going to do exactly the same thing for the vertical dimension. Hold left Control, click the top and bottom of the rectangle. That's going to give us this vertical dimension. And we want that to be 0.15 meters. So now that our sketch is fully dimensioned, what we're going to do is go up to the top here, click Generate. Now, if we go to the Modeling tab, we should see under the XY plane that our sketch has in fact been generated. Now what we're going to do is we're going to make the surface from our sketch. To do that, we're going to go up to the Concept tab here, click on that. That's going to open up this drop-down menu, and we want to click on Surfaces from Sketches. So that's going to open this little menu here in the Details view. We're just going to click Apply, and then select Sketch 1. And that should be good. And then the only thing left to do now is click Generate again, and that will give us a new body, this surface body here. And then the last thing we need to do is just change some of the settings for this surface body. So one of the things we want to do is rename it. In the Details view here, you click here. You want it to be named Air. And then for this fluid/solid setting, we're going to change that from solid to fluid, which we can do using this drop down here. And the very last thing we want to do is save the project. So click the save icon. And now once it's saved, we should be all good to close this window and return to the workbench. Back at the workbench, you should see this green check mark has appeared in the geometry tab, just verifying that we've completed that step. The next step in making our simulation is to create a mesh from the surface we generated. To get started making the mesh, just double click on the mesh tab. That should bring up a new window. This is the meshing window. This is where we're going to make the mesh that ANSYS uses to do the simulation. First thing we want to do is click on Mesh in the outline window, and then in the details box under the default settings, we want to change the element size to 0.02 meters, and then hit Generate, and that should generate our mesh. We're not done just yet. We want the simulation to be higher resolution close to the duct walls to capture the boundary layer effect. So to do this, once our mesh is generated, we're going to right-click on Mesh, and then under the Insert drop-down menu, we're going to click on Inflation. And then where next to Geometry, where it says No Selection, we're going to click, and then we're just going to click on our rectangle, and then hit Apply. And then where it says No Selection next to Boundary, we're going to click, and then holding left control, we're going to click on the top and bottom of our rectangles and apply there as well. And then the last thing we want to do for this is just make sure we're on the smooth transition setting and that the maximum layers is set to 5. And then we hit update, and that should generate our new mesh. And once that's generated, the last thing we're going to want to do is name some of our boundaries. So if I just click on the leftmost edge of the rectangle here, click that, and then right click, we can create named selection. And then for this one, we're just going to call it the inlet. And then we're going to do the same thing over here on the right. So click the rightmost edge, and then right click, create named selection, call this one the outlet. And now if we click and drag like so, we can select both the top and bottom simultaneously. And now if we right click and create a named selection, the selection will have both of those edges, and we'll just call this duct wall. Okay. Now if we click on mesh, we can visually confirm that the elements are smaller close to the duct wall than the ones in the middle, so that's good. And after we've saved the project, we are good to close out of this window. Back at the workbench, there should be a green check mark next to mesh. If there isn't, then that's okay. Just right click on the mesh tab and then hit update right here. The green check mark should appear. Now that we've generated our mesh, the next step is going to be setting up and running the actual simulation. To get started, just double click on Setup and then click Start on the Fluent launcher. This is Fluent. This is what's going to simulate our duct. So what we need to do is specify some of the conditions for our simulation. Let's just start at the top of the list on the left and work our way down. So to start with this just general settings, we want to make sure we're using the steady state analysis, which we are. Next, we're going to expand the Models tab, double click on Energy, and then check this box here. And now we're going to double click on the Viscous tab, and we want to make sure we're using the standard K omega model. So we change that, and then we hit OK. Next, we're going to check that we're using the correct material properties for air. So expand the materials icon, and then under fluids, double click on air. And just make sure that all of these properties look okay. They do, so we can close that. Now we're going to set some of the boundary conditions. So we open this boundary conditions menu. We go to the inlet, double click on the inlet. And from here, we can specify the inlet velocity to be 2.4 meters per second. And then if we click on this thermal tab, we can set the inlet temperature to be 380 Kelvin. We apply that and then close this menu. Now we go to the wall conditions. We double click on duct wall. That will bring up this menu. And here we want to go to the thermal tab again, and then set the thermal conditions to convection. And then we want the heat transfer coefficient to be 6 watts per meter squared Kelvin. And then the free stream temperature is going to be 273 Kelvin. Then we hit apply, and we can close that as well. So now that that's all kind of set up, we can go down to this solutions section, click on methods. And then here we just want to make sure that we're using the second order upwind and second order upwind methods for energy and momentum, which we are, so we can close that. And then go down to where it says initialization, double click on that and just hit initialize. And once that's done, we can go to run calculation, double click on that. And then here, we want to change the number of iterations from 0 to 1,000. And then we can hit calculate. So now that's done calculating, we can take a look at our results. So in order to do that, we go down to the results section and expand where it says graphics, and then double click on contours. That'll bring up this window. We want to see contours of temperature and static temperature. So just make sure that's the option selected there. Hit save and display. And now we can close this. Go up to this top ribbon and click where it says view. And then go over here and click views. And then we want the front view. Then hit apply and then close. And now the last thing for us to do is just visually inspect that these results look good. So if we zoom in here, we can see that the inlet temperature is about 380 Kelvin. And now if we go to the other side and zoom in over here, we can see the outlet temperature is about 358, which is what we'd expect, and that the duct wall temperatures are lower than that. So it all looks pretty good. So now it's just a matter of going up to File, saving the project. And at this point, we can exit out of Fluent and go back to the workbench. Once you're back at the workbench, you should see a green check mark has appeared next to the Setup and Results sections here. If you don't see that, you can just right-click on one of them and hit Update, and that should fix the problem. So now that we've run the simulation, we can start analyzing some of our results. To get started on that, we just double-click here on Results, and ANSYS will take us to a new window. This is the Results window. This is where we're going to finish up the final step of running our duct simulation. To get started, we're going to go up to the top left and open up the Insert menu. And then we're going to add a streamline. That'll open up this menu down here in the bottom left. And in this menu, we want to specify that we want the streamline to start from the inlet and to have a maximum number of points of 3. And we hit apply. That will generate the streamline. And now we want to do something similar for a contour. So we go back up to Insert. We click on Contour. Hit OK. That brings up this menu. Now we want the contour to have the variable of temperature. And we want the location to be symmetry 1. We hit apply. That'll create the contour. And the last thing we want to do for the contour is go over to render and change the transparency to 0.6 so we can see the contour and the streamline at the same time. Hit apply again. And now it should look something like this. The next thing we're going to want to do is create a line at the inlet. So to do that, we're going to go up to location, click on there, and then we're going to click line, hit OK. That's going to bring up this menu. Now to create a vertical line at the inlet, we need to specify 2 points. We want the first point to be at the origin, so 0, 0, 0, that's good to go. And we want point 2 to be at 0, 0.15, and 0. And that should create our line. If we hit apply, that has been created. Now, the next thing we're going to do is we're going to make a chart for the temperature distribution across that line. We're going to go up here to this icon, click on that, hit OK. That brings up another menu. So down here, we're going to go to the data series tab. And we want to specify that the data source is that line we just created, line 1. Then for the x-axis, we want the variable to be y, or height. And then for the y-axis, we want the variable to be temperature. Now we hit apply, and that should create a chart that looks something like this. So the last thing we need to do in the results window is find the last step for this simulation is to find the Nusselt number at points along the length of the duct. This can be done using the code that's been provided. Go up to the Tools menu in the top left and click on it. Then at the bottom of this drop-down menu, click on the Command Editor. Then in this Command Editor, paste the code. Once you've pasted the code, just click on the Process button. This runs the code, which outputs a table containing the Nusselt numbers at evenly spaced points along the duct. That should show up in the outline window in just a second. There we go. Under table 1, you see there are the values we're looking for. And that is how to simulate 2-dimensional airflow through a duct in ANSYS.